clicking on this video. Today we're going to be practicing partial fraction decomposition with quadratic factors. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Now here, in this problem, we have x plus 1 as a denominator, and we have x squared minus 5x plus 6. Now, in previous videos, we've talked about how to do partial fraction decomposition, but what you want to do is you want to be able to be sure that you can factor down whatever you have. And in this case, we have a quadratic, and we can factor this as x plus 3 times x plus 2. So this is not an irreducible quadratic. This is like some of the previous ones that we've seen in other videos. So when we write out the decomposition, it's going to be x squared minus x minus 8 all over quantity x plus 1 times x plus 3 times x plus 2. And so that's going to be a over x plus 1 plus b over x plus 3 plus c over x plus 2. So then we're going to multiply everything by x plus 1 times x plus 3 times x plus 2. And so we're left with x squared minus x minus 8, and that equals a. Now x plus 1 is going to cancel, and we're going to be left with x plus 3 times x plus 2. With b, we're going to cancel out the x plus 3, and we're just going to be multiplying x plus 1 times x plus 2. And then with c, we're going to be multiplying x plus 1 times x plus 3. Now we need to expand these three out. So we have a times x squared plus 5x plus 6 plus b times x squared plus 3x plus 2 plus c times x squared plus 4x plus 3. And so when we distribute that, we get ax squared plus 5ax plus 6a plus bx squared plus 3bx plus 2b plus cx squared plus 4cx plus 3, no x. All right. Now in this case, we're going to have to break this apart. And so first, we look at everything with an x squared. And we've got an a, b, and a c. And all of that has to add up to 1x squared. So that means 1 equals a plus b plus c. Then we look at the terms with x's. And so here the coefficient is -1. So -1 is going to equal 5a plus 3b plus 4c. And then finally, we have this term that doesn't have any x attached to it. That should be 3c. And so that's going to be -8 equals 6a plus 2b plus 3c. Now this one we'll solve with a calculator. So I'm going to first need a 3 by 3 matrix, and I'm going to write out the coefficients for these. So 1, 1, and 1 are the coefficients here for a, b, and c, and then 5, 3, and 4, and then 6, 2, and 3. And we're going to write the inverse of that, and then I'm going to need a 3 by 1. And so now I need these three numbers, 1, -1, and -8. So that leaves us with a equaling -3, b equaling 2, and c equaling 2. So when we distribute this, we have x squared minus x minus 8 all over x plus 1 times quantity x squared plus 5x plus 6. And all of that is equal to a, which is -3 over x plus 1 plus 2 over x plus 3 plus 2 over x plus 2. Now in this case, we were able to factor this quadratic into linear factors. But let's look at the next one. Now with the next one, we have x cubed minus 8. Now this is going to factor into 3x minus 5 on top, and then on the bottom it's going to be x minus 2 times x squared plus 2x plus 4. Now this quadratic is irreducible. We can't factor this. So with partial fractions, the way we deal with this is first we have x minus 2. We're going to write that as a. And then we're going to write x squared plus 2x plus 4. And because this is an irreducible quadratic, on top it has to be linear. So that means we can't just have b. We need bx plus c. And it can't just be bx because there could also be a constant up on top as well. So that's why we have bx plus c. That's a linear function, a degree 1, whereas a is just a number. That's degree 0. So now we're going to multiply by x minus 2 times x squared plus 2x plus 4. So on the left, we're going to be left with 3x minus 5, and that equals a times, and we're going to be multiplying x squared plus 2x plus 4. And then we have bx plus c, and so we're going to cancel out the x squared plus 2x plus 4, and we're going to be multiplying x minus 2. So when we distribute this, we get ax squared plus 2ax plus 4a. Here we've got bx squared minus 2bx plus cx minus 2c. Now this is all equal still to 3x minus 5. So what's equal to 3x? Well, any term with an x. So this term, and that term. So the coefficient 3 is equal to 2a minus 2b plus c. Our constant is a negative 5. And so that's going to be this term and this term. So that's equal to positive 4a minus 2c. And then, well, there's no x squared, but there are these x squared terms. And so that means the number in front of x squared is 0. And then we have ax, we have a plus b. We don't need the x squareds there. All right, so we've got our system of equations, so we'll use a matrix to solve this one. And we need a 3 by 3 first. So first we're going to write out the coefficients. So that's 2, then negative 2, and 1. For the second line, we have 4. Now there's no b, so that means it has a coefficient of 0, and then c is negative 2. And then here we have 1 for a, 1 for b, and then nothing for c. Then I have a 3 by 1, and that I'm going to put these numbers, 3, negative 5, and 0. All right, so we get these crazy numbers right here, and looking at my setup, I don't think I made a mistake here. So what that means is that I'm just going to use my calculator and tell me what are these as fractions. So a is 1/12, b is negative 1/12, and c is 8/3. So that means 3x minus 5 all over x cubed minus 8. That's 1/12 over x minus 2 plus negative 1/12 x plus 8/3 all over x squared plus 2x plus 4. And so there is our partial fraction decomposition for this one. Now on the next one, here we've got this 4th degree. Now really, when you see a 4th degree like this, one way you can work this problem is you can say, wait a minute, let's let x squared be substituted for something else. We'll call it y. And so this numerator becomes y squared plus 6y plus 8. Well, this we can factor. We're used to factoring quadratics. This is going to be y plus 4 times y plus 2. And when we substitute back the x, we've got x squared plus 4, and we've got x squared plus 2. Now, neither of those can be factored down. Both of these are irreducibly quadratic. So when we write this out, we're going to have 3x cubed minus 2x squared plus 12x minus 12 all over, and then we have x squared plus 4 times x squared plus 2. And so we're going to break this into x squared plus 4 for one fraction and x squared plus 2 for a second fraction. Now these are both quadratic, so that means on top they have to be linear. Ax plus b and cx plus d. And we use different letters because we don't know if these are the same. So now we're going to multiply by this denominator here. We have x squared plus 4 times x squared plus 2. All right, so we have 3x cubed minus 2x squared plus 12x minus 12. And so we're going to have ax plus b times x squared plus 2. And then we have cx plus d times x squared plus 4. And now we distribute this. So we have ax cubed plus bx squared plus 2ax plus 2b. And similarly here we have cx cubed plus dx squared plus 4cx plus 4d. Okay, now here we've got all the terms, x cubed, x squared, x, and then a constant. So 3x cubed, let's underline those with x cubes. So these two have to add up to 3. So 3 is going to equal a plus c. For the x squareds, that's going to be negative 2 equals these two right here, b plus d. And then here, these are my x's, so that's 12, and that's going to equal 2a plus 4c. And then finally, negative 12 is going to come from these two. So negative 12 equals 2b plus 4d. All right, I'm going to use a calculator here. And so this is going to require a 4 by 4 matrix because we have 4 variables, 4 equations here. So on the first one, we have an a, so there's a coefficient of 1. No b, so that has a coefficient of 0. C has a coefficient of 1. D, there is none, so it's a coefficient of 0. Now in the next one, we have 1b and 1d. So we have that. Now for this one, we have 2a and 4c, so 2 and 4. And then we have 2 and 4 for b and for d. So then finally, we put a 4 by 1 and we put in these numbers here. So 3, negative 2, 12, negative 12. And so we get a to b equals 0, b is 2, c is 3, and d is negative 4. So when we write all this out as our answer, we have 3x cubed minus 2x squared plus 12x minus 12 all over x squared plus 4 times x squared plus 2. Now there is no a, there's just b, so it's just a constant of 2 over x squared plus 4. And then c is 3, so 3x minus 4 all over x squared plus 2. Okay. And so now, for our last problem, here we have x squared plus 4, but that is squared. So that works just like a linear factor when it's repeated. So we're going to write it like this, x cubed plus x squared all over x squared plus 4 quantity squared. And so we have x squared plus 4. We start with that, and then we have x squared plus 4 quantity squared. Now, because it's a repeat, we start with this, and with a quadratic that we can't factor, we have it linear. So ax plus b. Now, every time you repeat, you just repeat what you have here. So that's also going to be a linear, cx plus d. So we multiply this by x squared plus 4 quantity squared. So we got x cubed plus x squared. And so here we're going to cancel one of the x squareds plus 4. So we have ax plus b times x squared plus 4 plus, now both of these will cancel, leaving just cx plus d. Now we need to distribute this out. So we have ax cubed plus bx squared plus 4ax plus 4b plus cx plus d. Now, we only have one term here with x cubed. So that makes that part easy. So 1 has to equal a. And also, we only have one term with x squared. So that means b also has to equal 1. But what about the terms with x's? Well, those have to equal 0 because there is no x here. So 0 is going to equal 4a plus c. But since we already know that a equals 1, we can go ahead and say that, well, 0 equals 4 plus c, so c equals -4. And in a similar way, these are constants. There's nothing there, and there's nothing up over there. So that has to equal 0. So we have 4b plus d. And since b has to equal 0, since b has to equal 1, we can solve. So 4 plus d. So -4 equals d. So we didn't need a calculator for this one. So when we write this out, we have x cubed plus x squared all over x squared plus 4 quantity squared. And so a is 1, so that's x. b is 1, so plus 1, all over x squared plus 4. And then c is -4x minus 4, all over quantity x squared plus 4 quantity squared. So there is our partial fraction decomposition for this one. Thanks for watching. If you liked the video, give it a thumbs up. You have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.